Hello and welcome to this GCSE Science Revision video for Core Chemistry on oil and its uses. In this video we will cover fractional distillation, cracking, polymerization, burning and the production of ethanol. Crude oil forms naturally over millions of years from the remains of living things. Most of the compounds in crude oil are hydrocarbons. These are compounds that only contain the atoms hydrogen and carbon and are chemically bonded together using covalent bonds. There are different types of hydrocarbon, but one of the most abundant ones in crude oil are alkanes. Now, alkanes are a family of hydrocarbons that share the same general formulae, which is CnH2n plus 2. The smallest hydrocarbon is methane, only containing one carbon atom. Methane has the lowest boiling point, followed by ethane, then propane, then butane. The longer the length of the hydrocarbon, the higher its boiling point will be. For instance, CH4 is a gas at room temperature, whereas propane, which is C3H8, is a liquid at room temperature. Fractional distillation is a form of distillation that separates a mixture into a number of different parts called fractions. A fraction will not contain a pure form of hydrocarbon, but a number of different hydrocarbons of similar length. In fractional distillation, a tall column is fitted above a mixture with several condensers coming off it at different heights. The column is hot at the bottom and cool at the top. Substances with higher boiling points condense at the bottom. Substances with lower boiling points condense further up. The crude oil is evaporated and it vaporizes and condenses at different temperatures as it moves up the fractionating column. This diagram shows how a fractionating column will separate crude oil into a number of different fractions. Each of these fractions have different properties and different uses. The fractions at the top of the column have lower boiling points and are shorter in carbon length. The fractions at the bottom of the column have high boiling points and longer hydrocarbon lengths. Fuels made from oil containing large hydrocarbon molecules are not very efficient. They do not flow easily and are difficult to ignite. Crude oil often contains too many large hydrocarbon molecules and not enough short hydrocarbon molecules. So, to meet demand, we crack the large hydrocarbon molecules into shorter chain ones. So, cracking allows large hydrocarbon molecules to be broken down into smaller, more useful hydrocarbon molecules. Fractions containing large hydrocarbon molecules are vaporized and passed over a hot catalyst, which breaks the bonds between them. The first stage in cracking involves long-chain hydrocarbons being heated until they turn into a vapor. This is what we call the feedstock and is pumped into a reaction vessel. A catalyst of zeolite crystals is then added. This lowers the temperature needed to break the hydrocarbons up. The long-chain hydrocarbon molecules are broken down into smaller ones. This reaction is called cracking and produces alkenes which have double bonds. The mixture of cracked molecules is pumped back into the fractional distillation column where they are separated. During the reaction, the catalyst becomes coated in carbon, so is pumped into a regenerator where the carbon is burnt off. This produces the gas carbon dioxide. The clean catalyst then flows back into the reaction vessel to be used. In this reaction, we produce alkenes. Alkenes are hydrocarbons that contain a carbon-carbon double bond. The number of hydrogen atoms in an alkene is double the number of carbon atoms. The general formula for an alkene is shown below. One common alkene that you'll come across in the exam is ethene, which has 2 carbon atoms. Alkenes can be used to make polymers. Polymers are very large molecules made when many smaller molecules join together end to end. The smaller molecules are called monomers. An alkene is a monomer. During the process of polymerization, the first stage is that ethene, which is an alkene, with a double bond is pumped into the vessel. Because it has a double bond, it is reactive. The double bond between the 2 carbon atoms is broken by a high temperature that causes the atoms to vibrate until the bond breaks. Another ethene monomer bonds to the first one, which is called addition polymerization. The polymer chain grows as more ethene monomers bond together. Branching occurs at high temperatures and pressures if a catalyst is not used. The general formula for an alkene that goes to make a polymer is shown below. To start off with, you need to change the double bond into 2 single bonds. The single bonds come out at the end of each carbon molecules, after which you can put brackets around it to show the individual monomer that has made up the polymer, and little n, which represents the number of monomers. We burn fuels to produce energy. When these fuels burn, the atoms in the fuels combine with oxygen from the air to make new molecules. For instance, coal is made up of mainly carbon atoms. When it burns, it forms carbon dioxide. Petrol and diesel fuels are also hydrocarbons. When they burn in air, they produce carbon dioxide and water vapour. Some of the problems caused by burning fossil fuels are that they produce carbon dioxide, which leads to global warming, carbon monoxide, which can lead to health problems, soot particles, which can lead to global dimming, sulfur dioxide and nitrous oxides, which can increase acid rain. One experiment in which we can look at the products of burning is shown in this diagram. As we burn a fuel, the gases from it are sucked through a series of pieces of equipment. In the first piece of equipment, the water in it is condensed by the cold ice around it, which causes the cobalt chloride paper to go from a blue colour to a pink colour. The remaining gases are then pulled through lime water, which will turn milky white if carbon dioxide is present. Ethanol can be made by reacting ethene with steam. A catalyst of phosphoric acid is added to ensure a fast reaction. This process continues as long as ethene and steam are fed into a reactor. The general formula for this is ethene plus steam goes to form ethanol. The ethanol formed in this way is very, very pure. The second way to form ethanol is by fermentation of glucose. Sugar from plant material is converted into ethanol and carbon dioxide by fermentation. The enzymes found in single-celled fungi such as yeast are natural catalysts that make this happen. Unlike the reaction involving ethene, this is a renewable process as we can always grow more sugar. The big problem is that it does not produce very strong ethanol, and the ethanol that it produces is not pure. So remember, when you're revising, turn off any distractions. Revising earlier is better than revising later, and quality revision is better than quantity revision. Good luck with your chemistry exams.